Chapter 5. Energy and Light. Energy. Conductive and insulating materials. When you had a cold, you were surely advised to drink lemon tea. If the tea seemed too hot, you waited for it to cool down a bit. So hot things don't always stay that way. Once the water is turned off the boil, it begins to cool. The process continues until the temperature of the water in the kettle is equal to that of the room. This is due to the transfer of thermal energy or heat between bodies of different temperatures. The body with higher temperature gives up heat to the body with lower temperature, warming it. Imagine pouring hot tea into a cup. At first the mug is cold, but little by little it will warm up as the heat of the tea will be transferred to the mug. To fully understand this process, let's talk a little about energy. This is closely related to the movement of the particles that make up matter. In the case of cold water, for example, the particles move very slowly, while the particles of hot water move extremely fast. Hot water contains a lot of energy. That is precisely why it is used for heating homes. Hot water circulates through metal radiators. They will heat up and in turn will transmit heat to the air in the room, warming it. This is similar to putting a kettle of water on the stove. The flame of the stove will heat the kettle, which will transfer heat further to the water, which will begin to boil. Materials that allow heat to pass through them easily are called conductors of heat. Metals such as iron, aluminum, stainless steel, or copper are good conductors of heat. Thermal conductors are useful when we need to cool or heat things. A metal pan, for example, will easily transfer the heat of the steak inside. Imagine you are pouring hot water into 2 mugs, one ceramic and one metal. In which one will the water cool faster? What explanation do you find for this phenomenon? What happens if you touch the hot handle of the kettle on the stove? You will remember in the future, and you will not repeat that mistake. A transfer of thermal energy will occur between the hot handle and your hand. Your hand is at a different temperature than the handle, being much cooler. Since the transfer of energy is always from the high temperature object to the low temperature object, in this case, the hot handle will transfer heat to your fingers and you will burn yourself. But what if you're going to use a thick textile glove to grip the handle? Your hand will be protected and you will no longer feel the heat. Explication: the fabric does not allow heat to pass through because it is insulating. Materials that do not allow heat to pass through them are called insulators. A good thermal insulator helps cold materials stay cold and hot ones stay hot for longer. Wood, plastic, cotton, wool, mineral wool, polystyrene are some examples of heat-insulating materials. What applications of the insulating properties of materials in everyday life do you know?